A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. So you know how every conference talk and blog post is telling you to containerize everything, and then you actually tried to set up a dev container for your little side project, and suddenly you've written more Docker configuration than actual code. And now I need to explain to my future self why we needed a 2,000-word configuration file to accomplish something that could have been a bash one-liner.
This is a genuinely important question, though, and I think the ecosystem has shifted enough that the old heuristics don't apply anymore. Docker Desktop changed its licensing in 2024, VS Code's Dev Containers extension has seen massive adoption growth, and new Python tooling like UV has fundamentally changed what setup actually looks like. That's a perfect framing. And it's especially acute in the Python ecosystem because Python already has this whole ecosystem of environment management solutions that have been battle-tested for decades.
We appreciate you, Minimax. Anyway, Daniel's prompt is diving into exactly this tension. When does environment isolation justify its overhead for solo developers? Raw Python versus Dockerizing versus dev containers. Right, because Python's not like some other languages where you really desperately need containerization just to have a consistent environment. Python's been doing dependency isolation since before containers existed.
And I think it's worth unpacking that comparison because it puts things in perspective. If you look at JavaScript, for example, Node has this notorious history of dependency hell. You've got NPM, you've got conflicting versions of the same package being installed in different nested node modules folders, you need tools like NVM just to manage different node versions.
And the core question is really about cognitive overhead versus isolation benefits. What does each approach cost you in setup time, mental model complexity, and debugging friction?
The thing is, solo developers face fundamentally different trade-offs than teams. A team can amortize setup costs across many people and many services. Right. And that's not a knock on containers, it's just recognizing that Python gave developers this capability early. What's worth noting is that Python 3.12 introduced some meaningful performance improvements that reduce the need for container-based optimization in many scenarios.
And that's where the 45-minute Docker setup for a fast API microservice starts to feel painful. Let me put some concrete numbers on this so we can actually compare. Now let me back up and make sure we're on the same page about what dev containers actually are. The term usually refers to VS Code's Remote Containers extension, which has been around since 2019. The basic idea is you have a devcontainer.json file that specifies how to build your development environment, and then VS Code spins up a Docker container and runs your code inside that container instead of on your host machine. So it's not even about deploying to containers. It's about using containers as the development environment itself.
That's the key distinction. You're not necessarily shipping this container anywhere, it's just for local development. The promise is that whoever checks out your repo can run one command and have an identical development environment with all the right versions of Python, all the dependencies, everything configured correctly.
And the reality is a bit more complicated. You create an environment, install your dependencies, and you're off. For a simple project with 3 dependencies, you're looking at maybe 5 minutes total.
First, you've got the dev container JSON, which specifies things like which base Docker image to use, what extensions to install in VS Code, what port forwarding to set up, whether to mount your source code as a volume or copy it into the container.
And then there's usually a Docker file underneath all of that. The ecosystem solved most of Pip's historical complaints. Here's a concrete example of what I mean. Last month, I needed to set up a small data processing script for a client. It needed pandas, OpenPixel, and a few utility libraries. Using UV, I ran UV init, added the dependencies, and had a working environment in under 2 minutes. The project structure was created, the virtual environment was set up, everything was configured. I was writing actual code 30 seconds after deciding I needed to write code.
That's the workflow people need to internalize. The overhead isn't in the setup anymore. The overhead is in choosing which tool to reach for.
That's a real benefit sometimes. But is it worth the daily friction?
That's such a good point. This is what I call the solo developer paradox. Dev containers solve a coordination problem. When you have 5 engineers on a team, maybe 20, and everyone needs the same environment, containerization pays off huge.
You hit Dockerizing when you have dependency complexity that virtual environments struggle with. And I don't mean 3 packages. And you might never have that problem. I've worked on solo projects for years. I set up my virtual environment once. Maybe I write a small setup script, and then I never think about it again.
So data science projects, ML work, scientific computing.
Exactly those cases. I worked with someone maintaining a geospatial processing pipeline. Getting GDAL to compile correctly on macOS took 2 days. Getting it working in Docker took 2 hours, and it worked identically on their colleague's Linux machine and the CI server. That's where the math flips. But let me add another dimension. It's not just about the initial setup, and that friction matters more for solo developers because there's no one else to blame. If you're on a team and someone has to wait an extra minute for the container to spin up, that's just the process.
That reproducibility guarantee is real. But you're describing situations with serious external dependencies. What about a normal web developer building a Flask app with 5 dependencies?
For a solo developer building a Flask app with SQL Alchemy and a couple of request libraries, stay raw. The Docker overhead actively hurts you. You add build contexts, image layers, port forwarding, volume mounting for hot reload. Now you're managing a Docker compose file just to see your changes without rebuilding. The cognitive overhead doesn't match the actual problem you're solving. And let me tell you about a project I inherited. The previous developer had Dockerized a Flask app with exactly those dependencies. The Docker setup took longer to understand than the actual application code. That adds up fast. If you're doing 5 or 6 short coding sessions in a day, that's 15 to 18 minutes just waiting around.
Now here's where I want to add a concrete number. Research on developer productivity consistently shows that context switches and interruptions have a significant cost. Some studies suggest it can take 15 to 30 minutes to fully regain deep focus after an interruption. So if you're breaking your flow every time you start a container, you're not just losing 2 minutes of waiting time, you might be losing a significant chunk of refocusing time. That's a very different calculation. They paid the full cost and got 0 benefit.
The second order effects are where it gets expensive. When you're developing inside Docker, your debugging workflow changes completely. You've got forwarded ports, volume mounts that sometimes don't sync properly, file system event handling that differs from native development. PyCharm and VS Code handle this reasonably well now, but it's still an abstraction layer that can bite you. Let me give you a specific scenario. You're debugging an API endpoint that reads from a file. In native development, you edit the file, save it, and your code picks it up. Don't forget the editing experience. VS Code's dev containers are pretty good now, but you're still running inside a container. File watching can be laggy, especially on macOS. IntelliSense might be slower. Git operations might be slower. You trade some of the polish of native development for the consistency of the container.
The file watching issue is particularly worth unpacking because it trips up a lot of people.
Dev containers take the Docker approach and add VS Code's remote containers extension into the mix. You define a development container with all your tooling, extensions, and settings. When you open the project, VS Code spins up the container and connects your IDE to it. You get the full IDE experience, IntelliSense, debugging, the works, but running against the containerized environment.
Which sounds amazing in theory, and for teams, it kind of is. Everyone gets identical tooling, identical environment versions, same extensions. You eliminate the whole "it works on my machine" class of problems that scales linearly with team size. We've all been there. The bug is a semicolon, but you're debugging your container configuration for an hour because you assume it must be something complicated. When everyone's VS Code has the same extensions configured the same way, you can actually help each other with configuration issues. You know that their setup matches yours.
When you install those in a dev container, you're building them inside the container, which takes time and can sometimes fail if you don't have the right build dependencies installed. But that growth is heavily weighted toward teams and open source projects where onboarding new contributors is expensive.
So for a solo developer maintaining 12 microservices, you're saying dev containers become worth it around service number 4?
Roughly, yeah. The setup cost gets amortized across your services, and suddenly you're not maintaining 12 different local environments. You have one definition, and all your services inherit it. But here's the critical part for solo developers. When you Dockerize or use dev containers, you're taking on maintenance burden that would normally be distributed across a team and an organization. Who handles the Docker configuration when it breaks? You do. Who updates the base images for security patches? You do. Who reads the release notes when Docker or VS Code releases a breaking change to dev containers? You do.
That tracks. If your Docker configuration breaks, there's no teammate to help debug it. You own the entire stack, including the parts that exist purely for development convenience.
The 3-dependency rule I've developed is this. If you have more than 3 non-Python standard dependencies that have native code or complex installation procedures, seriously consider Dockerizing. Below that threshold, the overhead isn't justified. You're spending more time managing the container than you'd ever spend resolving the dependency issues you're supposedly preventing.
But inside a Docker container, you're often building from source because the pre-built wheels might not match your exact Python version or build configuration.
That's a real friction point that doesn't get talked about enough. I had a project that started as a weekend hack. It was a simple API scraper, maybe 100 lines of code. I Dockerized it because it might grow. 6 months later, the project was still essentially 100 lines of code with the same dependencies. The Docker setup added friction to every debugging session without ever providing value. And this is where it gets really messy, because CUDA versions need to match your GPU drivers, your PyTorch or TensorFlow version, and the CUDA runtime inside the container.
And that connects to project lifespan and deployment target considerations. Are you eventually deploying this to a containerized environment? Kubernetes, ECS, Cloud Run? And managing those version constraints is a full-time job.
It also means your development environment mirrors production more closely. That has real value for debugging production issues. But if you're deploying to Heroku or a traditional VPS, you might never need Docker for development. Here's the thing though. Development Docker and production Docker are often different. Your development Docker file might include test dependencies, debugging tools, hot reload configurations that production doesn't need. So when you look at it from the ground up, what's the actual baseline for raw Python development? What are we comparing against?
For most solo Python developers, the baseline is creating a virtual environment with Python mvm-env, activating it, and installing your dependencies with pip.
The multiplier effect is real. Once you hit 3 or 4 services with overlapping dependencies, the coordination overhead of managing separate virtual environments starts to hurt. Each service might need a different version of the same library. You end up with complex activation scripts or just constantly reinstalling packages. Docker Compose solves this elegantly. Each service runs in its own container with its exact dependency versions. And that works for the vast majority of projects. Flask, FastAPI, Django, data processing scripts, automation tools, most of what solo developers actually build doesn't have any special requirements that demand containerization.
Now here's where I think dev containers actually earn their keep. The first major use case is when you have complex service dependencies. Let's say you're building a fast API application that talks to PostgreSQL, Redis, maybe a message queue.
Though I'd push back on solo devs adopting dev containers for microservices too early. Start with Docker Compose for your services and virtual environments for isolation. Only move to dev containers when the setup and debugging friction actually exceeds the benefits. Dev containers add another layer of abstraction on top of Docker. But with Docker Compose, you can define all those services and spin them up together with one command.
Right. Your dev container can run Docker Compose, and now your Python code is talking to real PostgreSQL and Redis inside the container, but your code is also running in a container. Everything is consistent and self-contained.
That does sound nice, but Isn't that a bit of a shotgun approach? What if you just need PostgreSQL for this one project and you don't want to Dockerize everything? I see this with architecture astronauts all the time. They build a microservices infrastructure for a monolith application because we might need to scale. They never scale, and they spend their entire career maintaining infrastructure for a problem they never had.
What about the debugging friction point? Because I feel like this is where dev containers get sold as magic, but actually add friction in unexpected ways.
But again, for solo development, you're probably just developing on one platform. File watching for hot reloads sometimes requires configuration. If you're mounting volumes, the file system events might not propagate correctly depending on your operating system and Docker version. What about the AI angle? Daniel mentioned in his background that AI-assisted development tools increasingly expect containerized environments. What's that about?
This is getting more relevant. Tools like GitHub Copilot Workspace, Cursor, and other AI coding assistants are starting to assume they can spin up reproducible environments.
It's better now with the VirtuoFS file system driver, but it's still something to be aware of. If you're doing heavy file I/O during development, a native environment might feel snappier than a containerized one, even with modern Docker improvements. So the argument is, maybe you should containerize now so you're ready for the AI tooling of tomorrow. You might need to configure Docker to allow core dumps or adjust your signal handling. These are solvable problems, but they require understanding the Docker networking and process models that you never need to understand in native development.
Locking yourself into a dev container setup today because some AI tool might benefit from it tomorrow seems premature to me.
I tend to agree. And honestly, most of these AI tools work fine with a standard Python environment. They're not requiring containers yet. Do you have a team, or are you onboarding contributors frequently? Consider dev containers as an investment.
For that to work safely, they need isolation. If an AI agent is going to install packages or run scripts, you probably don't want that happening directly on your host machine. But here's a nuance. Even long-term projects can start raw and migrate to Docker later when the dependency complexity actually emerges. The migration is usually straightforward. You're right, and that's a whole conversation about AI safety and trust. But let's stay on topic. The point is that even in the AI use case, containerization is about isolation and reproducibility, not about the specific developer tooling.
The deployment target is the third axis. If you're deploying to containerized infrastructure, Dockerizing development matches production. If you're deploying traditionally, you're adding complexity for no practical benefit during development. Now let's talk about maintenance burden, because this is something that gets glossed over. When you add a dev container to a project, you're adding configuration that needs to be maintained. Your base image might get outdated. Your dependencies inside the container might drift from your actual requirements. You need to rebuild the container periodically to pick up security patches.
I've seen solo developers who spent more time debugging their dev container setup than they ever spent building their actual application. That's a net negative. If you're consistent in your own practices, you might not need the isolation guarantees that teams require. Here's an interesting thought experiment. That's such a good point. With a virtual environment, the mental model is simple. There's a folder, it has your packages, you activate it, done. But with a dev container, you need to remember the interaction between your devcontainer.json, your Docker file, Docker Compose if you're using it, VS Code settings, and then how all of that maps to your actual source code.
So what's the practical advice here? When should a solo developer actually use dev containers? That asymmetry matters more for solo developers than it does for teams where someone might specialize in developer experience. But it also means you have full control. You don't need to convince your organization's platform team to update something. You're the decision maker and the implementer.
What do you think about the argument that dev containers are becoming table stakes for open source projects specifically? You mentioned the adoption growth.
For open source, the calculation shifts. Reducing friction for potential contributors has massive leverage. But for the typical solo developer building a REST API, a data processing script, a machine learning model that only runs locally, I'd say stick with virtual environments. The setup is simpler, the iteration cycle is faster, and you're not paying the complexity tax for a benefit you're not using. The barrier to entry dropped from Read the contribution guide, install these 12 dependencies, configure your editor, figure out why it's not working. To open in VS Code, click Reopen in Container.
You could use Docker Compose for your services without using VS Code's Remote Containers extension. You pick the level of containerization that matches your actual needs.
That's the just enough Docker approach. Don't containerize for the sake of containerizing. Containerize when there's a specific problem being solved. The setup cost is borne entirely by you, and you rarely benefit from the consistency guarantees that make the trade-off worthwhile for open source. But there is an edge case. If you're a solo developer who collaborates informally with others, maybe you pair program occasionally or share code for review, dev containers can still make sense, and the project worked perfectly fine. No containers needed.
On the flip side, I've seen solo developers building microservices with different Python versions for each service.
That's the interesting question. Avi handles dependency resolution and management so well that many historical reasons for Dockerizing have diminished. What about data scientists? They often have different needs than web developers. Astral, the company behind Uvi, is explicitly focused on making Python tooling fast and reliable. They've already dramatically reduced the friction that used to drive people to Docker.
A container with the right CUDA version pre-configured can save a lot of grief.
But if you're just doing pandas work and standard scikit-learn stuff, you don't need that. But you still need to understand the abstraction. You still need to know how volumes mount and how ports forward. Here's a prediction I'll make. Can you give us a checklist of questions someone should ask themselves? Dockerizing will be the exception, not the default, for a much wider range of projects.
Third, am I working across multiple machines? If yes, containers can ensure consistency. Fourth, does my project have complex native dependencies or GPU requirements? If yes, containers can encapsulate those.
The mental model matters. Even with the best dev container setup, you occasionally need to understand what's happening underneath. When something breaks, you need to be able to debug at the Docker layer, not just the application layer. Those are good questions. And the beautiful thing about Python's ecosystem is that you can start simple and add complexity later if you need it. You don't have to containerize from day one. If you understand how containers work, how networking works, how volumes work, dev containers become a convenience layer on top of that understanding. So let's summarize what we think solo developers should take away from this. First, dev containers are not the default. They're a tool with specific strengths, and you should reach for them when you have a specific need, not out of habit or dogma.
Second, understand the costs. The startup time, the debugging complexity, the maintenance burden. Make sure you're getting enough value to justify those costs for your particular situation.
Third, Python's native environment tools are genuinely good. Virtual environments, poetry, these are not inferior alternatives to containers. They're the right tool for a lot of jobs. Here's a concrete example of the wrong reason to Dockerize. You Dockerize your Flask app because you want to learn Docker. That's a valid reason to learn, but it's not a valid reason to Dockerize your actual project. The question isn't, should I use dev containers? The question is, what problem am I actually trying to solve? And is a dev container the simplest way to solve it?
That's the right frame. Now, one thing I want to touch on before we wrap is the future direction. Where is this all heading?
Yeah, because the landscape keeps changing. More AI tools, more cloud-based development environments, things like GitHub code spaces, and VS Code's dev containers getting more mature. VS Code dev containers are more accessible than ever. AV makes virtual environment management nearly frictionless. But here's what I want listeners to take away. The tools are better. The question is whether the problem you're solving actually requires the tool you're reaching for. There's a kind of developer who always uses the most powerful tool available, not the most appropriate one. And that would potentially make local dev containers less relevant, because the cloud environment handles the consistency problem.
Potentially. But cloud development environments have their own issues. Latency, cost, dependency on internet connectivity, concerns about code privacy. I don't think local development is going away anytime soon.
Probably not. There's something to be said for having your tools running on hardware you own. There's a famous quote about premature optimization being the root of all evil. I think premature infrastructure is equally problematic. Don't build the microservices architecture before you have a microservices problem. Don't Dockerize before you have Docker-level complexity.
The 2-week test, the 3-dependency rule, the deployment target consideration. These aren't laws. They're heuristics that capture common patterns. Your specific situation might warrant breaking them, but you'd better know why you're breaking them. Here's my addition to those heuristics, the colleague test. See you then.
We're going to leave listeners with a framework they can apply immediately. Evaluate your next Python project against these criteria. What's your dependency complexity? How long will you be working on this? Where does it deploy? Are you working alone or collaborating? What happens when something breaks? The answers will point you toward the right approach. But here's my parting thought. The best developers I know have strong opinions about their tools, loosely held. They know why they make the choices they make, but they're willing to reconsider when the situation changes.
The answer might surprise you. Sometimes the boring, straightforward choice is the right one, and sometimes the sophisticated tooling genuinely pays for itself. You just have to do the math. And sometimes the math requires accounting for things that are hard to quantify, like your own sanity when you're debugging a container configuration at 11 p.m. versus the peace of mind knowing your development environment matches production exactly. Those things matter too.
Thanks as always to our producer, Hubert Flumingtop. Big thanks to Modal for providing the GPU credits that power this show.
This has been My Weird Prompts. Find us at myweirdprompts.com for RSS and all the ways to subscribe.
This episode was produced using Minimax M2.7. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the close from sloth, from man, from long-eared host. My Weird Prompts, until next time, stay curious, keep weirding.